Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Iqbal Rushaidi bin Muharram. So I am from Group 4. So for this experiment, it's called Bourdon Tube Pressure Gauge. So this is experiment 6. Okay, I'm going to start. For the first one is abstract. The objective of the experiment is to perform pressure calibration on a Bourdon tube pressure gauge using a dead weight tester. In this experiment, we use a device called Bourdon tube pressure gauge in order to calculate the pressure occur due to weight of the load by manipulating the weight with increment of 0.5 kilogram and decrement of 0.5 kilogram. We record the data for each test by loading and unloading the weight itself. So then in this experiment, we need to compare the experimental data that we obtained from the experiment and the actual value. So when we obtain these two, we will get the percentage error of 34.7% and 13.0% for loading and unloading method respectively. So okay, next. So for objective, the objective of this experiment is to calibrate a Bourdon tube pressure gauge using dead weight. Okay, next for introduction. Okay, for an engineer, pressure is such an important aspect for us because they often being used in calculation, such as Bernoulli equation have a pressure. So, pressure also can be related to weight of load and the surface area of the contact. So there are many instruments or devices in this world have been invented in order to calculate the pressure value of certain object or certain that exerted by a certain force. In in this experiment, we use device called Bourdon tube pressure gauge to measure the pressure of the loads that we are going to use in this experiment. So when we use the Bourdon tube pressure gauge, we will get the gauge pressure. So by applying pressure to so how we want to use this device, we use it by applying a pressure to one of the tube at the Bourdon pressure gauge. The tube will be straightened, thus pushing the pointer to a specific value at the meter. It means that when we put the weight, so there is a force exerted on the piston, and it will push the fluid, and thus will make the pointer point at the value of the pressure exerted by the weight at the meter at the. So next. Okay, for the theory, it consists of elliptical cross-section bent into a circular arc as shown. The pressure indicates its difference between the system pressure and to the external pressure, and is usually referred to as the gauge pressure. So the pointer will point at zero indicator, which means it is a gauge pressure. When the tube is open to the atmosphere, the pressurized fluid inside the tube will make the tube stretch and move the pointer. So next, calibration means checking the pressure gauge reading against a very accurate device. Dead weight tester is one of the example of calibration device that we can use. So this device consists of piston, internal chamber filled with fluid such as oil, uh, cylinder, and adjustable plunger. So the weight are placed on the top of the piston. Thus the force will directly exerted on the fluid in the chamber. The force exerted at the piston oil surface contact, which means in this area. You can see here, this is the area between the fluid and the piston. So where at this area happen the pressure, occur the pressure. The force exerted at the piston oil surface is the total weight of the piston and the load of weight. So as you can see, the piston itself has its own weight, and also the load itself has its own weight. So we must total the mass between these two things and to calculate the force. So next, okay, so we can use the formula P equal to F over A. So F is equal to mg. So to calculate, this is force to calculate the pressure, where the F is the force exerted on the fluid surface in the chamber, and the mass is total mass including the mass of the piston. So which means the mass of the load and the mass of the piston total together. Okay, and A is the cross-sectional area of the piston in the square meter, in a meter square, I'm sorry. And the G is the gravitational acceleration with a unit meter per second square. Okay, here is the Bourdon tube pressure gauge. So you can see here the blue one is the pointer, and this is the value of the pressure. So when we put the load on the piston, so the pressure will happen, and the pointer will point at the amount of pressure that exerted by the weight on the surface contact. Okay, that's all. Thank you.
So the methodology of the experiment. So the first step, 1 kilogram of piston was inserted into the Bourdon tube's cylinder and make sure there is no air bubble trapped inside this in the small tube. So the first reading of pressure is recorded. Then one dead weight was placed or added on top of the piston and the second reading was recorded. Another dead weight was added on top of the piston and the third reading was recorded. So the steps 3 was repeated until all dead weight is all added on top of the piston and all reading of each dead weight was added were recorded. So after the experiment is done, all dead weight was removed. So this is the result for each mass added and the total mass. So for the mass, for the no dead weight was added. So the total mass was the actually the weight of the piston. So the pressure exerted by total mass is 30.9 kilopascal. The percentage of loading 35.3% and the unloading one is 35.3, same. And after that 0.5 kilo mass was added, and so the total mass is 1.5 kilo. 46.4 kilopascal pressure, and the percentage of error for loading 34.7, and the unloading one 13%. Next, another one kilo mass added. Oh, I think it is 0.5 more. So the total mass for the mass added, the dead weight added is 1 kilo. So the total mass of the total mass is 2 kilo. So the pressure exerted by total mass 61.8 kilopascal. The percentage of error for loading 20.2 and the unloading one 9.4%. Next, the total mass is 2.5 kilo. So the pressure exerted by total mass is 77.3. Percentage error for loading 20.2, same with the previous one, and the unloading one 9.4%. Next one, the total mass for 3 kilo. The pressure exerted by total mass, which are 92.7. The percentage of error for the loading one is 13.7%, and the unloading is 6.5%. The total mass is 3.5 kilo. The pressure exerted by total mass uh 108.2 kilopascal. The percentage error for loading is 16.8%, and the unloading one is 22.0%. The next one, the total mass 4.0 kilo. The pressure exerted by total mass 123.7 kilopascal. The percentage error for loading is 17.0%, and the unloading one is 2.1%. Next, the total mass for 4.5 kilogram. The pressure exerted by total mass is 139.1 kilopascal. The percentage error for the loading one 13.7%, and the unloading one is 0.6%. Next, the total mass is 5 kilo. The pressure exerted by total mass is 154.6 kilopascal. The percentage error of loading is 14.8% and the unloading one 3.5%. Next, the total mass for 5.5 kilo. The pressure exerted by the total mass 170 kilopascal. The percentage error for the unloading 13.1% and the unloading one 5.9%. Last one, the total mass 6 kilo. The pressure exerted by total mass is 185.5 kilopascal. The percentage error for loading is 13.7% and the unloading one is 13.7%. So the first discussion, percentage of relative error for the theoretical measure experiment pressure gauge. So a piston of known area A is loaded by a known weight F. Therefore, the theoretical pressure is the cylinder is P theoretical equal to F over A. The measured experimental pressure can be obtained from the reading of Bourdon tube pressure kilo. So mass of piston is 1 kilo. So the cross-sectional area of the piston 3.1731 times 10 power of negative 4 meter square. So the tube pressure exerted by piston equal to mass of pistons times 9.81 times 10 power of negative 3 divided by cross-sectional area of piston. So 1 kilo times 9.81 times 10 power of negative 3 divided by 3.1731 times 10 negative 4. So the value is 30.9 kilonewton per meter square. The two pressure exerted by total mass is total mass times weight plus piston times 9.81 times 10 power of negative 3 divided by cross-sectional area of piston. So 1 point in bracket 1 plus 0.5 times 9.81 times 10 power of negative 3 divided by 3.1731 times 10 power of negative 4. So the answer is 46.4 kilonewton per meter square. So the average reading of calibrated pressure 30 plus 31 plus 30 kilopascal divided by 3 times 1 kilonewton per meter square divided by 1 kilopascal equal 30.3 kilonewton per meter square. So the percentage error for the loading measure value. So in bracket and modulus measure value minus actual value divided by actual value times 100%. So modulus 30.3 minus 46.4 divided by 46.4 times 100%. So 34.7% percentage error for loading. Same goes to the unloading one, the formula. So but the value is different. So 40 times minus 46.4 divided by 46.4 times 100%. So 30% percentage error for unloading.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hanafi bin Hamizan and I will be the last presenter for our group. So for the source of error and method to minimize the error. So there are a few types of error that occur in this experiment. So the first one is there might be some air bubble trapped inside of the tube when we insert the piston into the cylinder. So how to minimize is make sure there is no air bubble during when we insert the tube. The next one is adding some dead weight on top of the piston, external force or pressure might be affect the reading. So how to minimize is that we have to repeat the same step at least 3 times and calculate the average of the value to get more accurate answer. So the last one is the eyes of the observer is not perpendicular to the scale, which is the meniscus, and this will affect the value. So how to minimize is that make sure that the eyes of the observer is perpendicular to the scale of the to the scale of the meniscus to avoid any parallax error or any mistaken reading. So for the repeatability and accuracy of this equipment, uh, so for the repeatability in here means that the value of the agreement between the repeated measurement of the same mass of weight under the same condition. While for the accuracy is the average value that we recorded is almost or the same with the true value. So for the conclusion, as a conclusion, the Bourdon tube pressure gauge is measured every time the weight increase. The gauge pressure is recalibrated as the accuracy of the gauge reduced over time by using the dead weight. The percentage of error for loading is 34.7%, while for the unloading is 13.0%. The uncertainties in this experiment could be from random error and systematic error. There are many errors that affect the result of this experiment. Therefore, in order to overcome the error, the experiment need to repeat a few times to get an average value. We also need to make sure that all the apparatus is functioning well to reduce the percentage error. That's all from us. Thank you.